So we have a second example of rationalizing denominators using conjugates. In this scenario, I see I have a 4 minus rad 7. In order to cancel that radical 7, I would have to multiply by the missing part for a difference of squares. That's what a conjugate is. So I'll multiply the top and the bottom by 4 plus rad 7. 4 plus rad 7. As I FOIL this, first with first will be 16. The outer, inner, I don't have to worry about because it's a difference of squares. I know it's guaranteed to drop out. And so I have a minus. Positive times a negative is negative. You should always have a minus there. And rad 7 times rad 7 is just a regular 7. If you recall, that's a perfect square. It becomes 7 squared, which automatically comes out. So I get this 16 minus 7. Now, the way I do these problems, I like to work the denominator all the way out. So 16 minus 7 is 9. And then I'm looking for that opportunity to cancel anything in the denominator with what I have in the top. The way I set these up, I see that this 3 and the 9 can be reduced. And then I don't have to worry about that all or none concept that I presented in the last video. And so I can go ahead and reduce the 9, call it a 3, reduce the 3, call it a 1, which means that I'm just left with this 4 plus rad 7, which I could bring down. And then I got this strange looking answer, 4 plus rad 7 all over 3, which hopefully you recognize that would be irrational in its totality because it has that radical that cannot be simplified. Let's move on, do more examples here. Example 3, let's say I have 5 over radical 2 minus, let's do a plus radical 11. Sometimes you can have radicals in both places. So in this situation, I would multiply by the conjugate. I'll multiply the top and the bottom by these same two terms, just the opposite sign. Radical 2 minus radical 11. Radical 2 minus radical 11. And so then the next step, I work with that denominator. A radical 2 times a radical 2 is 2, minus automatically. Outer, inner cancels out. Radical 11 times radical 11 is just a regular 11. 2 take away 11 is negative 9. This does not pose an opportunity where I can cancel the 5 and the negative 9, which forces me to go ahead and distribute that 5 across these two terms. So this becomes a 5 radical 2 minus 5 radical 11. I'm just looking at the numerator in case I lost you. Now I'll bring that down because I cannot add or subtract that. 5 rad 2 minus 5 rad 11 all over negative 9. That's a good answer. There's always little nuances that we got to throw in here. I'm fine if you answer this way, but if you had, say, a multiple choice test or something like that, you may see equivalent answers. And so we've talked about how sometimes you have to cancel all or none. You cancel from each and every part or no parts. You can also see where maybe they take this negative 9 or this negative from the 9 and they put it upstairs and distribute it. So an equivalent answer to this might be where we take this negative and we distribute it to the top, meaning that I could call this negative 5 rad 2 plus 5 rad 11 all over positive 9. See, they're the same terms, they only differ by a sign. And so this is an equivalent statement. That becomes huge as you develop and you get into deeper levels of math. You have to be able to recognize equivalent forms. I'd like to do another example in this video. So let's keep going. Call it example 4. And this time let's go 2 radical 3 for our numerator, 3 radical 2 minus radical 5 for our denominator. So here we've got radicals all over the place. In order to get rid of these radicals, I'd have to multiply by this newfound idea. It's called a conjugate. It says you take those same two terms and you multiply them, you just change the middle sign. So this would be 3 rad 2 plus rad 5. I'm supplying the missing part for a difference of squares. And so this time we start with our denominator. And notice I always give myself plenty of room. Don't squeeze it all together and then get confused with your work. Give yourself room to work. As I do my first with first, this may be something that takes a little bit of practice on your part. I'm going to write this out to the side so I can explain what I'm doing as I do this. I have to do the free element with the free element and the jailed with jailed. So 3 times 3 is 9, and then I'm going to write that right here. That gives me 9. The radical 2 times the radical 2 is a regular 2. So that becomes 9 times 2, which is just 18. That was my first with first. The outer, outer, inner, inner, for like the third time, we know we don't have to calculate it because it has to cancel out. You've created a difference of squares. So I'm just left with this last with last. So I know I have a minus automatically. And then a rad 5 times a rad 5 is just a regular 5. That means that I will have a 13 for my denominator. 18 minus 5 is 13. I don't have an opportunity for the 13 to cancel with this multiplier up here. So it's telling me I should go ahead and distribute. And so I'll do just like I was doing over here. Free with free. 2 times 3 would be 6. And then the radical components, radical 3 times radical 2, nobody would get out, so I'll go ahead and multiply those, and I'll call that radical 6. That's the first part of the distribution. I'll go to the second part. 2 times 1 is 2. And then a radical 3 times a radical 5 is radical 15 for the same reason. No part could get out from underneath the radical. So I'll call that radical 15. I'll go ahead and bring these down. 6 rad 6 plus 2 rad 15 all over 13. I'm looking for that opportunity to cancel all or none. It has to be from every part or no part. There is no opportunity to cancel here, so this would be my final answer. And so there's a couple more examples on rationalizing denominators using conjugates.